Hi, my name is Robert Faber, and I'm a new postdoc at University of Washington Atmospheric Sciences, working with Kyle Armour and Aaron Donahoe. My interest is in polar warming. So why are we so interested in polar warming? Well, one reason is that the Arctic is uh, warming faster than anywhere else on Earth. So this is a figure showing the change in surface temperature from an ensemble of global climate models, and it matches observations pretty well. And the math's been normalized by 1 degree of global mean warming. So what this means is that although the Earth warms by 1 degree globally, individual regions are warming faster or slower. So you see that in particular in the equator, the planet is only warmed by about 0.75 degrees, whereas in the poles, it's warmed by anywhere from 2.5 to 3 degrees. So the Arctic is warming quite a bit faster than the equator and the rest of the globe. And this is generally matches what we see in observations. But individual climate models show quite a spread. So this figure on the right is showing each individual climate model as one of these different red lines. And you can see in the poles that the range of warming goes from anywhere from 2 degrees to 4 degrees of warming. And that makes a big difference for the people and the ecosystems living in the Arctic. So in order to better constrain future Arctic warming, we'd like to better understand what are the mechanisms that are causing this polar implication in the first place. And that's what my current research project is all about. So just to explain a few of these mechanisms, this is a little schematic. We have the Arctic atmosphere, sea ice, and the Arctic Ocean underneath. And so one mechanism is that a lot of heat and moisture is transported from the south into the Arctic. Maybe that's responsible for polar amplification. Another possibility is that it's the vertical structure of radiation and clouds, which play an important role in retention of heat in the Arctic. The third possibility is the loss of sea ice at the surface, revealing warm ocean underneath, which is causing the surface to warm. Or possibly it's some combination of all of these. And so we'd really like to be able to investigate these different mechanisms. This is hard to do in a fully coupled GCM though, because the model's too complicated and too many things are happening at once for us to be going and just turn, say, one knob and change the horizontal transport. So what I'm in the process of doing is creating an idealized model, a simplified model that allows us to investigate these different mechanisms more directly. So what we're doing is we're using an atmospheric column model, so one vertical column extending up and down through the atmosphere. And we're coupling that to some representation of horizontal transport, as well as a surface model that has both ice and open ocean in the Arctic. And our goal is, by using this model, to investigate a whole range of hypotheses about what are the ultimate causes of polar amplification, and hopefully use that information to constrain the spread in our future projections of Arctic warming. My email's at the bottom. I'd really love to hear from you if you have any thoughts or comments on this project, or polar climate feedbacks more generally. Thanks very much.